The operation begins when the worker carefully lifts the large steel dish-shaped workpiece and places it onto the central support of the back's automatic flanging machine. The component is positioned so that its open rim is perfectly aligned with the forming rollers. Precise positioning is essential because the machine will shape the edge of the part into a uniform flange that must meet strict dimensional tolerances. Once the flange blank is correctly seated, the operator activates the clamping system. The machine firmly locks the workpiece in place, preventing any movement during rotation. After this, the forming head, which carries several heavy-duty rollers, moves toward the rim of the steel part. The machine then starts rotating the workpiece at a controlled speed, allowing the rollers to make smooth and continuous contact with the edge. As the rollers press against the rim, they gradually bend the steel outward. This forming action is not done in a single pass. Instead, the rollers apply increasing pressure step by step. With every rotation, the edge is pushed further into the desired flange profile. The automatic control system ensures that the force, feed rate, and angle of the rollers remain constant, producing a flange that is even all the way around. Throughout the process, the worker monitors the operation, checking alignment and surface quality. When the target flange shape is achieved, the rollers retract, the rotation stops, and the finished flange component is ready to be removed for the next production stage. At the quarter-mile Edinburgh residential development, BAMTech reinforcement was chosen as part of a modern and efficient concrete reinforcement solution. This project belongs to a series of over 100 successful installations across the British Isles, where BAMTech technology has proven its reliability and efficiency in large-scale construction. The BAMTech system is based on prefabricated mats, also known as reinforcement carpets, which are manufactured off-site under controlled conditions. Each mat consists of pre-welded steel bars rolled into a compact form for easy transportation. When delivered to the construction site, the mats are ready for direct installation, minimizing preparation work. The installation process is straightforward and efficient. Using a crane, the rolled mats are lifted onto the concrete deck. Once in position, the slings are removed, and the mats are simply rolled out across the designated area. This rapid deployment replaces the conventional method of individually placing and tying steel bars, which is often time-consuming and labor-intensive. The simplicity of the process ensures that large floor areas can be reinforced in a fraction of the time required by traditional techniques. One of the main advantages of BAMTech is its ability to drastically reduce labor requirements and installation time. Because the reinforcement arrives in a ready-to-use form, fewer workers are needed on site, and installation can proceed without interruption. This leads to faster construction cycles and lower overall costs. In addition to speed, the system guarantees consistent quality because each mat is produced using computer-controlled machinery and advanced planning software, which ensures accurate bar spacing, correct mat dimensions, and precise reinforcement positioning. This digital precision eliminates common site errors and ensures compliance with the design specifications. Another major benefit of BAMTech reinforcement is material efficiency. The optimization software used during the design stage calculates the exact steel requirements for each area, reducing excess material without compromising structural integrity. This intelligent use of resources results in significant material savings compared to traditional mesh reinforcement. Overall, the BAMTech installation at Quarter Mile Edinburgh demonstrates how modern prefabricated reinforcement technology can enhance productivity, quality, and sustainability in concrete construction. Through reduced labor, shorter installation times, improved precision, and material savings, BAMTech provides a highly efficient alternative to conventional reinforcement methods, contributing to the success and innovation of contemporary building projects. The 13,000-ton open-die forging press is a monumental piece of heavy industrial equipment engineered for shaping large steel ingots with exceptional force and precision. Manufactured by SMS Mir in September 1982, this 4-column push-down water hydraulic press remains one of the most powerful machines in the forging sector. Its robust construction allows it to withstand continuous high-load operations while delivering controlled deformation of metal. With an impressive capacity of 13 meganewtons, 13,000 tons, the press can forge massive components required in industries such as power generation, shipbuilding, oil and gas, and heavy machinery. Its generous dimensions further enhance its capability. The machine offers a maximum press stroke of 4,500 millimeters, providing ample vertical movement to work on large billets through multiple reduction and shaping steps. Additionally, its daylight of 8,000 mm allows operators to handle tall or bulky workpieces with ease, improving process flexibility. The press also features a substantial distance between columns 6,750 by 2,650 mm, giving wide workspace access for manipulators and handling equipment. This structural layout ensures stability during extreme forging loads while maintaining precise die alignment. Overall, the 13,000-ton forging press stands as a testament to advanced hydraulic engineering, enabling the production of high-strength, high-integrity forgings essential for demanding applications. NuScale Power and Sustainability have entered a pivotal phase as production forging begins for the first NuScale Power modules. These factory-built units, including their containment structures, are manufactured entirely off-site and then shipped directly to the plant, eliminating field fabrication and reducing both project costs and schedule risks. This milestone marks a major step toward commercialization, ensuring NuScale remains on track to meet customer and project delivery commitments. With this progress, NuScale continues advancing its mission to provide the carbon-free energy essential for a sustainable future for all. Welding a gutter from the inside is a precise process that ensures durability and leak resistance in roofing and drainage systems. The procedure involves carefully joining gutter sections by welding along the interior seam. This method provides a smooth and sealed connection, eliminating gaps where water could escape. The welder must maintain steady control to achieve uniform penetration and a clean finish, which is crucial for the gutter's long-term performance. Compared to mechanical joints or adhesives, interior welding delivers a stronger bond and greater reliability under heavy rainfall or changing weather conditions. As a result, it is widely used in professional construction and repair projects for metal gutters. The dredging and sand removal for the new Suez Canal represented an extraordinary engineering challenge due to the project's massive scale and, above all, its unprecedentedly tight deadline. Completing such an ambitious undertaking in less than 12 months had never been achieved before. The Suez Canal, the world's shortest shipping route between Europe and Asia, required expansion to increase transit capacity and stimulate industrial activity in the region. Therefore, a new parallel canal was constructed, designed with a depth of 24 m, a width of 240 m, and a total length equal to 1/3 of the existing waterway. To execute this demanding task, Jandanul Group deployed 7 powerful cutter suction dredgers, JFJ Danul, Hondius, Koipu, Leonardo da Vinci, IBN Batuta, Leonardo da Vinci, and Junhee. Together, these vessels delivered an impressive total installed diesel power of 134,720 kilowatts. Their contribution formed the majority of the dredging effort, supported by the company's significant investments over the past decade, which resulted in the world's largest and most capable cutter fleet. As the canal soil consisted mainly of compacted sand music with intermittent layers of stiff clay, cutter suction dredgers proved to be the ideal machines for efficiently breaking, extracting, and pumping the material away to create the new navigation channel. The IHC backhoe dredger Alberto Alemán Zubierda is a powerful and highly specialized dredging vessel designed for excavating hard underwater materials with precision. Built by Royal IHC, this dredger features a robust hydraulic backhoe crane mounted on a stable pontoon platform, allowing it to operate effectively even in challenging marine environments. At the heart of the system is a heavy-duty bucket capable of breaking and removing tough materials such as rock, boulders, old revetments, and underwater concrete structures. Alberto Alemán Zubierda demonstrates its exceptional digging force as it excavates dense layers beneath the waterline using its long-reach boom and stick to deliver controlled, powerful strokes. The pontoon can be stabilized using spud legs, enabling the vessel to maintain precise positioning during critical operations. This ensures efficient material removal with minimal disturbance to surrounding areas. Backhoe dredgers like this one are essential for port deepening, channel widening, and infrastructure construction where conventional suction dredgers are ineffective. Royal IHC's engineering provides high reliability, advanced hydraulic systems, and optimized cycle times, making the Alberto Alemán Zubierda a key asset for heavy-duty dredging projects around the world. The steel plate is already positioned between the 3 rolls, and the bending process begins as the top roll moves downward to apply pressure. The 2 lower rolls support the heavy plate while the upper roll presses it from above, forcing the thick steel to start deforming. With a powerful hydraulic pressing force of 396 tons, the plate is squeezed firmly between the rolls, allowing plastic deformation to occur even in material up to 70 mm thick. As the rolls start rotating, the plate is pulled forward. While moving through the 3-roll arrangement, the steel gradually takes on a curved shape. The bending screaming is not done in a single step. Instead, the operator controls the downward movement of the upper roll in small increments. Each adjustment increases the curvature slightly, ensuring the plate bends smoothly without cracking or creating internal stress. As the plate passes through the rolls, its leading edge becomes curved first, followed by the middle and trailing sections. Because the plate is pulled 500 mm wide, maintaining even pressure across the full width is critical. The rigid frame of the diato bending roller keeps all three rolls perfectly aligned, so the curvature remains consistent from one side of the plate to the other. After the first rolling pass, the plate is fed back through the machine. The upper roll is lowered again to increase the bending radius. This multiple pass method allows precise control over the final shape, especially when forming thick and heavy plates. Each pass adds more curvature until the target diameter is reached. To avoid flat ends, the plate is often repositioned so that both edges can be pre-bent. By carefully adjusting the roll positions, the machine ensures that the ends are curved to match the center section. This creates a uniform cylindrical or conical form, depending on the production requirement. Throughout the operation, the rotation speed and pressing force are continuously monitored. The combination of high torque and massive hydraulic force allows the machine to bend extremely thick plates while maintaining a smooth surface finish. Once the desired curvature is achieved, the rolls are opened slightly, and the fully formed steel plate is released. It is then lifted away for the next stage of fabrication, ready to be welded into large pipes, pressure vessels, or heavy steel structures. Boscalis cutter suction dredgers are powerful vessels designed for dredging rock, clay, silt, and sand. They can be either self-propelled or stationary dismountable units, each equipped with a rotating cutter head that loosens the seabed. During operation, the dredger is firmly positioned using spuds and anchor winches. By pulling the side wires, the cutter head swings sideways around the main spud, allowing controlled cutting. The vessel advances through the spud carriage system as dredging continues. The cut material, mixed with water, is sucked into the suction mouth and pumped through long discharge pipelines or barges to designated reclamation or construction areas. MTCC operates a modern dredging fleet capable of handling major reclamation works across the Maldives. Since 2007, the company has deployed powerful IHC 1800 and 1600 cutter dredgers with 50 m dredging depth, along with the 3700 cubic meters hopper dredger Mahajarafu, ensuring efficient, self-reliant, nationwide dredging capacity. Trailing suction hopper dredgers are powerful ocean-going vessels designed to collect and transport sand and silt over long distances. Operated by Boscalis, these ships are essential for port construction, waterway maintenance, land reclamation, and coastal defense. Each dredger is equipped with 1 or 2 suction pipes ending in drag heads. Upon reaching the dredging site, the vessel slows down and lowers the pipes to the seabed. The drag head then moves steadily across the bottom, vacuuming a sand-water mixture that is pumped into the hopper. Dredging continues until maximum hopper capacity is reached. Depending on project needs, the vessel can discharge its load in several ways: rainbowing sand through a bow nozzle, pumping it ashore via floating or submerged pipelines, or releasing it accurately through bottom doors. This versatile system allows efficient and precise material placement for a wide range of marine works. The steel production process at Jorg's Marianne Hut begins with the preparation of sorted scrap, which is meticulously selected to ensure consistent quality. This recycled material forms the main input for their electric arc furnace, where intense electrical energy melts the scrap into liquid steel. Once fully molten, the steel is transferred to secondary metallurgy, a critical refining stage in which temperature, composition, and cleanliness are precisely adjusted. Throughout this phase, samples are taken at different points to verify chemical accuracy and guarantee that each steel grade meets customer specifications. After refinement, the steel moves to continuous casting. Here, the modernized casting machine forms the metal into 6 strands, producing billets with uniform geometry and structural integrity. These billets then enter the rolling mill, where advanced rolling stands shape them into bar and long steel products. Precision rolling units enable the production of extremely accurate diameters, while 3-disc stands ensure tight tolerances and allow quick adjustments to rolling dimensions. This flexibility shortens production times and supports a wide range of product sizes. Following rolling, the bars are cut to customer-defined lengths with high accuracy. Quality checks are performed continually, ensuring that dimensional, mechanical, and surface requirements are fully met. The finished steel is then prepared for shipment using streamlined logistics systems that deliver products exactly when required. Through recycling, precise metallurgical control, continuous casting, and automated rolling, the plant consistently produces high-grade steel tailored to demanding industrial applications. The manufacturing process of tower components at Gargalic Group follows a streamlined and fully integrated process. First, steel bars are laser cut to high precision before being transferred to advanced welding stations for structural assembly. Inverter welding is applied to ensure strong and uniform joints on all sections. Next, panels are produced and trimmed on a vertical cutting line to achieve precise dimensions. After shaping, each part is taken to the powder coating shop, where a durable protective finish is applied. Finally, the components are assembled in a dedicated installation area, completing a solid and precisely engineered tower structure, ready for installation. Modern Forge, a 4th-generation family-run company, operates facilities with over 35 production units and a workforce of 500. Specializing in alloy, carbon, and stainless steels, they produce shafts and precision parts for major markets. Their unique cross-roll forging process creates shafts up to 4 in diameter and 31 in long, using 28 hammers, including 9 high-speed automatic units, plus robotics for faster production. The plant features 5 forging presses, 1,600 to 4,000 tons, precision trim systems, cold coining, heat treating, machining, welding, and coating. Partnering with clients, engineers ensure accurate, cost-effective parts with rapid speed to market and predictive manufacturing software, all under ISO, AAS, and HR certifications. The steel grinding ball manufacturing process begins with the selection of steel bars to achieve the desired hardness and wear resistance. The sorted steel is melted in an electric arc furnace, and alloys are added in a bucket refining station to adjust the steel's properties. Shaping is then done by forging, casting, or precision rolling to form uniform spheres. After shaping, the balls are heat treated, which includes quenching in water or air to harden and tempering to increase toughness and impact resistance. In the finishing stage, grinding and honing refine the shape and surface quality. The balls are then thoroughly cleaned, and rigorous quality control, both automated and manual, ensures they meet strict standards for hardness, wear resistance, and dimensional accuracy before being packaged and shipped worldwide. Errata Grinding Material, part of the IA Group, specializes in the production of high-quality grinding materials, including steel balls, peps, and grinding rods. Each product is carefully manufactured and rigorously tested to ensure superior wear resistance, efficiency, and environmental performance. The company has contributed to drafting 6 industry standards for forged and rolled steel balls and holds over 20 patents, earning recognition from world-renowned mining enterprises such as China Minmetals, China Nonferrous Metals, China Gold, Zijin Mining, Rio Tinto, and Vale. Quality is the lifeline of the enterprise. High-quality steel balls play a critical role in grinding, effectively reducing cost and energy consumption. To support innovation, the group established the IA Advanced Materials Industry Research Institute in cooperation with the Institute of Metals of the Chinese Academy of Sciences, focusing on R&D, material preparation, and customized solutions. Raw materials undergo strict double inspection before entering production. Manufacturing is fully automated, with 15 computer-controlled grinding media production lines ensuring consistent quality across batches. The company maintains ISO 9001 certification and employs 360 degrees dynamic control management software to monitor every production stage. With an annual output of 300,000 tons, advanced logistics, and dedicated customer service teams worldwide, Errata Grinding Material ensures timely delivery and reliable support. Combining technological innovation, high efficiency, and customer-focused service, the company continues to lead the grinding material industry. The overhaul of the Howden WRV 510 compressor begins with carefully draining all lubricating oil to ensure a safe and clean working environment. External connections are then removed, including flange bolts from the suction and discharge ports. If present, the coupling guard and spacer coupling are detached to provide full access to the compressor's internals. Next, the discharge end cover is opened for initial inspection, followed by the removal of the suction end cover. The rotors are carefully extracted, and the thrust bearings are disassembled to allow detailed inspection of the balls and races. Every internal component is examined for signs of wear, damage, or deformation, ensuring that all parts meet the required standards. After inspection, all components undergo thorough cleaning to remove oil residues, debris, or contaminants that could affect performance. Measurements are taken for all journals, bearings, and other internal clearances using precise instruments to verify that they are within specified tolerances. Any worn or damaged parts are identified and prepared for replacement or refurbishment. Reassembly follows, strictly adhering to the original specifications of the Howden WRV 510. Rotors and bearings are carefully reinstalled, ensuring correct alignment and clearance. Suction and discharge covers are replaced, and all flange bolts and external connections are securely fastened. Finally, the coupling and guard are reattached, and the compressor is filled with fresh lubricating oil. This meticulous process restores the compressor to optimal working condition, ensuring reliable performance and longevity. Royal IHC is a global leader in the design and manufacture of integrated and highly efficient dredging vessels and equipment. The company supports a wide range of operations, including land reclamation, coastal protection, offshore trenching, port construction, and the extraction of sand and gravel. More than half of the world's dredging contractors depend on Royal IHC's advanced solutions, from trailing suction hopper dredgers and cutter suction dredgers to auxiliary vessels and specialized equipment. This strong trust demonstrates the company's ability to deliver excellent returns on investment while reducing the environmental impact of dredging activities. With innovative engineering and reliable life cycle support, Royal IHC continues to enhance the efficiency, safety, and sustainability of port maintenance and environmental dredging projects worldwide. The step-by-step process of disassembling and assembling the IHC cutting head underlines Royal IHC's pioneering role in technological innovation. The cutting head is screwed onto the cutting shaft, so disassembly begins by removing it. First, the operator loosens the three-part clamping ring located between the cutting shaft and the shaft neck. If a cutting ring is installed, the blocks must be cut with a torch. The cutter is then securely suspended from the hoist, secured with a chain around the arm to prevent the cutting head from tipping over and damaging the threads. Next, the shaft is slowly moved counterclockwise until the cutter is removed. Once removed, the shaft is cleaned, lightly greased, and all O-rings and seals are checked. The three-part ring is retightened or tack welded if a cutting ring is installed. To reassemble, the cutter is positioned so that the shaft and threads are aligned, checked by moving it slowly counterclockwise. Once aligned, the operator moves clockwise until the cutter head engages the cutting ring. Finally, the firmness is confirmed by lowering the cutter to the seabed or rotating it through the side lifting eye. The manufacturing of oversized seamless rolled rings and heavy walled shells begins with selecting high-grade steel ingots, which are heated in ultra-low emission natural gas furnaces. These furnaces, featuring capacities up to 10,000, 8,000 to 4,500 mm and temperature uniformity within plus or minus 5 degrees Celsius, ensure controlled heating for SA508-3 and other critical alloys. Once the ingot reaches forging temperature, it is transferred to the 13,500-ton open die hydraulic press, which provides a 7,000 mm headroom and a 5,800 mm opening. Under this immense pressure, the ingot is drawn out, upset, and pierced to form a hollow preform suitable for ring rolling or shell forming. For large reactor pressure vessel shells measuring 5,200*E4 600*3,000 mm and weighing up to 105 tons, the press shapes the wall thickness and geometry with high accuracy. When producing seamless rolled rings, the pierced preform is moved to the 16 m diameter ring rolling mill capable of handling rings up to W 16,000 mm with heights reaching 3,000 mm. Here, radial and axial rolls continuously compress the material, refining the grain flow and achieving exceptional mechanical integrity. After forming, components such as coke tower transition segments or nuclear-grade shells undergo heat treatment in split HT furnaces or large trolley furnaces 14,000*-7,000*-4,500 mm to achieve the required microstructure. Finally, precise machining and inspection guarantee high accuracy, high efficiency, and reliable delivery for critical heavy equipment applications. At the Bevel Gear Workshop, we are equipped with 10 of the most advanced CNC bevel gear cutting machines, including C60U, C100U, and GMC 160, all from Klingelnberg, Germany. Several high-precision bevel gear testing machines, such as GKP 851 and T200, along with measuring instruments P100 and P350, ensure top-level inspection. Our GMC 160 CNC machine is capable of processing large spiral bevel gears up to 2,500 mm in diameter using dry cutting to save energy and protect the environment. After soft cutting and heat treatment, hard cutting eliminates distortion and achieves surface roughness as low as raw 0.4, reducing transmission noise and extending gear life. With advanced testing and measurement systems, we maintain world-leading precision in spiral bevel gear production. The drive technology used in steel-making plants and rolling mills must meet the highest demands. Sturdy and reliable drive systems are essential to ensure top-quality products and maintain high plant availability for decades. SMS CMAG has specialized in the development, design, and manufacturing of drive systems and components, combining metallurgical plant and rolling mill process know-how with modern gear design to achieve optimum drive solutions. SMS CMAG's product range includes all drive systems for hot and cold rolling mills, as well as steel making plants. For rolling mills, SMS CMAG supplies main drive gears, mill pinion gears, and twin drive gear units, along with drive units for shears, edgers, sizing presses, and coil handling systems. Their flex and slipper type spindles are engineered to handle the highest torque requirements, such as those in BOF converters. Tilting drives are also supplied, with all gear components developed and manufactured in-house at SMS CMAG's headquarters and workshops in Germany. In recent years, more than €80 million has been invested to expand the Hilgenbach workshop, including a new gear-making shop where all major manufacturing steps for large drive units are integrated. This allows SMS CMAG to guarantee top quality and short delivery times. Thanks to the modern machinery pool, the company can fabricate gears with a module up to 40 and diameters of up to 6 m. The production of a large drive wheel begins in the welding shop, where fully mechanized submerged arc welding is applied to all joints. After welding, the gear wheels are annealed for stress relief, and the tooling is milled using state-of-the-art machines under the supervision of qualified personnel. Case hardening of double helical spur gears weighing up to 45 metric tons and measuring 4½ m in diameter ensures durability, followed by ultrasonic testing of the gear teeth. The tooth flanks are ground on profile grinders, and the finished gears undergo high-precision testing on a dedicated gear measuring machine. Gear housings are also produced in-house, and the complete gear units are pre-assembled with a gear contact pattern adjusted using eccentrics. This computer-aided adjustment ensures precise alignment and allows for corrections even after years of operation. The workshops at SMS CMAG in Hilgenbach are among the most advanced in Europe, especially in gear manufacturing. The 2014 maintenance campaign saw the Hopperdredger Prince der Nederlanden sustain Maas Vlak 2, where Bosch Alice partner in the Puma consortium continues 25-year upkeep of the Netherlands' largest hydraulic expansion. The dredging of the new Suez Canal was an unprecedented achievement completed within an extremely tight 12-month deadline. Designed to expand transit capacity between Europe and Asia, the new channel features a depth of 24 m, a width of 240 m, and runs one-third the length of the existing canal. Canal Group played a leading role, deploying 7 powerful cutter suction dredgers with a combined 134,720 kilowatts of diesel power. Their fleet, the largest globally, was ideally suited for removing compacted sand and layers of rigid clay. The operation begins when the worker carefully lifts the large steel dish-shaped workpiece and places it onto the central support of the back's automatic flanging machine. The component is positioned so that its open rim is perfectly aligned with the forming rollers. Precise positioning is essential because the machine will shape the edge of the part into a uniform flange that must meet strict dimensional tolerances. Once the flange blank is correctly seated, the operator activates the clamping system. The machine firmly locks the workpiece in place, preventing any movement during rotation. After this, the forming head, which carries several heavy-duty rollers, moves toward the rim of the steel part. The machine then starts rotating the workpiece at a controlled speed, allowing the rollers to make smooth and continuous contact with the edge. As the rollers press against the rim, they gradually bend the steel outward. This forming action is not done in a single pass. Instead, the rollers apply increasing pressure step by step. With every rotation, the edge is pushed further into the desired flange profile. The automatic control system ensures that the force, feed rate, and angle of the rollers remain constant, producing a flange that is even all the way around. Throughout the process, the worker monitors the operation, checking alignment and surface quality. When the target flange shape is achieved, the rollers retract, the rotation stops, and the finished flange component is ready to be removed for the next production stage. At the quarter-mile Edinburgh residential development, BAMTech reinforcement was chosen as part of a modern and efficient concrete reinforcement solution. This project belongs to a series of over 100 successful installations across the British Isles, where BAMTech technology has proven its reliability and efficiency in large-scale construction. The BAMTech system is based on prefabricated mats, also known as reinforcement carpets, which are manufactured off-site under controlled conditions. Each mat consists of pre-welded steel bars rolled into a compact form for easy transportation. When delivered to the construction